So please kind of open up, open your phone and scan this QR code. Let's do some questions. We just want to kind of prep you up for the session. Great. We have a good number of customers having more than 10,000, means more than 1,000 devices in their NSO environments. And the next question is about, have you performed NSO upgrade or migrations recently? Yes. And do you have to validate all the device connectivity before the upgrade or the migration from the old server to the new server? Okay, so the answer is no. So this is a kind of a problem that we've faced it. So we kind of wanted to kind of tackle in terms of ensuring everything is proper before upgrade as well as after the upgrade. That's the session is all about. Thank you for your answers. So now we'll get into the session.
What do you know about your devices information and how do you manage them? Good morning, everyone. This is Madhavi, technical leader in Cisco CX Automation Customer Delivery. I came from Texas, USA. I am here with Ishwar.
Hey, I'm Ishwar. I think I was talking about for a session yesterday. I'm a software consulting engineer with Customer Experience Group. I'm from India.
We observed different migrations, upgradations of NSO servers during our delivery. If you have a small group of devices, then it's easy to validate. If you have a large group of devices, thousands of devices, then it's very hard and time consuming. Our strategy is simplifying the complex processes as effective and efficient for both quality and quantity. As a part of automation community, we like to do the smart work rather working hard. Our today's agenda, why we need device statistics. We have to know about the device statistics information, where we can manage our servers, different environment servers information, and then some settings through command line arguments. And then we have demo and overview of reports. And finally, we conclude with a case study. Let us assume how many different types of environments we have to manage. Sometimes single instance of NSO server, sometimes HA environment with one master and many slave nodes. Sometimes we have to migrate our NSO servers from old environments to new environments. During that process, we have to validate our devices' connectivity. So we should know how many devices are connected, how many are not. How many devices are actively used and how many are stale devices. Each device belongs to how many groups, how many services for each device. Like that, lot of information we need to identify and we need to validate. For that reason, we need device statistics. Let us go more details about this information. So we are dividing into 4 categories here. First 3 categories represent the reports, what information we are gathering using this utility. The first one is the information what we are gathering, whether the device is NetSIM or not. Generally in production, we don't use NetSIM devices, but dev environments, QA stage, pre-production, sometimes we use NetSIM devices. So we want to manage both NetSIMs and the real devices. We want to know whether it is a NetSIM device or not. And then for each device, what is the host name, IP address, port, auth group of the device, and then the NED information of the device. And also, we gather the platform information, the model, platform version, and how many groups for this device, how many services for this device. Like this is gathering the information of the device, the first category. The second one, connectivity information. We try to establish the connection to make sure in that environment from NSO server to the device through network, we have the connectivity. For that, we do the ping. If ping is successful, then we do the connection. If connection is also successful, then connection success. Otherwise, either ping failed or connection failed, we will show the reason behind. Sometimes connection timeout, cannot reachable, and invalid SSH keys, like that, or invalid password. Like that, whatever the issue we are seeing, we want to show that information. So this is about the connection information. And the third one, we prepared an algorithm to understand whether the device is active or not. For that purpose, we took our hidden parameter in NSO. This is under devices, device tree, last updated. That is a leaf, hidden leaf in NSO. Whenever we do a change in the device, that time will be updated in that parameter. So we are using that future, and then we are giving. So how I am defining whether this device is active or stale, that depends upon, we have to decide. You want to decide your device is stale if you are not using in last 200 days, or 365 days, or 50 days. We can decide that one. So that tells the stale days information. And then here we are dividing into 3 categories. As per my stale days, for example, I am giving 200. If the device is active in last 200 days, then I am recognizing this one as an active device. Otherwise, within these 200 days, it was not used, no changes in the device, then it's unused. And then the third category, if you observe, we onboard the device, we have the connectivity, but if we are not doing the sync from, then this leaf, hidden leaf, last updated, will be empty. Then that device is not used at all. So we found those type of devices at customer environments. That's what the last category, not used. So these 3 sections we can use to generate the report. We have another section. If you don't want to delete any devices using this utility, we can skip that part. But first 3 sections we use to collect the information. The last one is also extra feature that if you want to do the cleanup, depending on whether it is stale device or not connected, depending upon the type of category, we can delete those devices also. So this is overall what features we are supporting here. Next, to set all these features. So once we are running this utility, we don't want to see all the information at a time. So we want to have some settings. So this is a particular setting. Default, it is serial. If you have 1,000 devices, it will go one after one to collect the information, to check the connectivity and so on. But if you want to do 50 devices at a time, parallel, so that time we can enable the parallel processing. The next one is the source of truth. How many devices? Default, all the devices of our NSO. If you have 2,000 devices, 5,000 devices, it will collect that information. Otherwise, we have some other features available, like few number of devices you want to generate report, then you can put comma separated devices information through a parameter. Otherwise, you can list out all the devices information in a CSV file. That is another option. And the third option, NED specific devices you want to generate. So only I want to get Nokia devices report or ALU-SR device, for example, XR devices information. So for that purpose, we can give that category also. So no need to go with all the devices at a time, we can filter them. And the third one, this is particularly for deletion process. If you want to delete all the stale devices, if you want to delete all the non-connected devices, or if you want to delete specific list of devices coming from CSV, like that you can use. So during the deletion process, we can see the dry run, we can enable it, and then before deletion, we can get the confirmation also, rather deleting straightly. So that is the another option. These settings we can do when we are running the report. And then the last one, some other settings. If you don't want to collect the NetSim devices information, so we can disable that part. And then every time we don't need to get entire information. So for that purpose, some parameters we can make it false, like I don't want to get groups information, I don't want to get services information, or auth groups, or environment, platform information. So we can decide what information we want, through our reports. Now coming to we divided into 3 scenarios. The first one, as mentioned, standalone server. So how can we set up here the environment and then which environment we want to execute? So for that, we have server information. So this is the file, server details. So there, not only one server information, you can go and set up all your environments information, the dev stage, pre-prod, prod, and in each environment, if you have 2 nodes or 4 nodes, we can set up in the JSON format. And then this is most important section. Here we are telling, okay, if you have 10 environments information in this file, but which environment we are trying to generate report. So that information comes here. And then primary server and secondary server. So what is that primary server? Here we have only one NSO, standalone. So we can give that one as primary. But actual purpose is, primary server is, it takes the source of truth, the devices list from that server only. And then it will go to different servers and compare. For that purpose we use, but here it's a standalone, we have only one server information. And then with those settings, we can go and run the utility. The next one is the migration. We have scenarios like the current environment, and then as per customer requirement, we set up a new environment with new operating system and so on, advanced operating system version. So at that time, we set up the new environment. So at that time, our validation should be like comparing current server and then the new server. So both servers information, here we have with IP, port, protocol, and role information. So this role is standalone, both are independent here. And then we are giving which environment, and here primary server is this one, and secondary server is here. So it will take the list of devices from the current environment, and then it will take each device and go and collect the information from first server and then second server also. So we get both servers information. That way it is easy to map and compare. So that is this purpose. And the third one, high availability. If you have master node and one or many slave nodes, at that time we can configure server information as a role master and second server, and any number of servers we can set up for all the slaves here. And then we can tell about the environment, and again primary server, your master server, and secondary server, it will be comma separated all slaves. So for that purpose, we can use comma separated here, and then we can execute this part. So here we can combine all these scenarios also. And how many servers we want to compare for each device, we can go ahead. Now I will hand over to Ishwar for the demo.
Thank you, Madhavi. Before starting the demo, I'll give a quick glimpse of what all terminals that we have. I hope it's visible for all of you in the back. No? So it's a video. I'm sorry, we will not be able to increase the size. But I think you'll be able to understand what we are trying to do here. On the top, we have node 1, which is the master server. And right side of it, means to your left, right? So this one is the slave server, And the bottom panel is the one which is used for executing the script to gather the reports and connectivity analysis. So let me start the demo. So I'm logging into the first server, NCS CLI, and I'm about to show you the HA status. You can see that the first node is the master. The current assigned role is master. And you can also see what is a slave node that is kind of being managed. I'm going to the next terminal, which is a slave terminal, just to show you the HA status. So the mode is slave. And you can also see the master ID as NSO node 1. Now going to the other terminal to execute a script to identify the statistics across devices across these two nodes. So here the important files to note are environment details.json, and the other one is the compare devices parallel processing.py. That's the actual utility. Environment details.json is the one where we provide all the or we store all the environment related details, like for example QA or prod or pre-prod, right? So here you can see that local testing is one environment. Local testing is one environment. Within that we store the IP, port, protocol, what is the role of that particular server, right? So local testing is having two servers, server 1 and server 2. We have defined even username and password as well. That's an option for you to store it here in the configuration file. And the next environment is test environment 1, that is having just one server, which is again like all NSO details, IP, port, and what is the role. Role is important. There are three types of role: master, slave, and standalone. Standalone is only particular to that server. The next one is the test environment 2. This is the one that we are going to use it for the demo. It has two servers, server 1 and server 2. Server 1 is pointing to the NSO node 1 and server 2 is pointing to NSO node 2. And server 1 role is master and server 2 role is slave. So the next environment is something, a QA environment. So there could be an environment where there could be one master and multiple slaves, right? So this QA is having one master and 3 slave nodes. So it could be n number of slaves. So we don't limit anything. And there is one more environment, staging, which is having just one server, standalone server. The next important thing to note is the command options. This is a place where you can define the default values for all the command line options so that you don't have to enter it again and again. There are a lot of options available with which you can actually mix and match it. The last one is the, I think we are talking about parallel count. We are highlighting it. So we can increase the number of devices for which you have to do the connectivity analysis at the same time. The next is the selected environment. Out of all the environments, what is the environment for which you want to run the tests? And within that environment, which is your primary server? Is it server 1 or server 2? Why primary server? Because that's the source of truth where you will query the devices, and then on top of that you will run the tests across. Now we are about to execute the script. The good part is if you're storing all the default values one time, I mean all the environment values, you don't have to do it again and again. You just need to select it. So after executing it, you can see that these are all the default values that are being passed back to that particular script. In case if you wish, you can go ahead and modify it. So if you're okay with that, you can go and give S. And after that, it is going to give you the selected environment, because just in case you do not want to kind of execute on a different environment, just to avoid unintended consequences. So here it is showing it, the selected environment is test environment 2, and the primary server is server 1 and secondary server is server 2. And if the username and password is not defined in the environment.json for that particular server, it is going to ask it dynamically here. So that's where there are two cases. If you want to store it there in the environment.json, you can store it. If not, you can actually go ahead and give if there is a security issue, if the server is not properly authorized or secured, you can go ahead and give the username and password here. So it asks for all the server which is not having username and password. So two servers, we haven't defined username and password, so it asked for both. And it completed executing. It is a simple environment. So it's not having a lot of devices, so it completed faster. Now we are looking at what's there in the generated reports. There are two important files to look at here. Compare environment execution.log. It has a detailed log for the checks that it performed against each devices. The important result of this particular utility is the comparison report. It compared against two servers, so we are using IP addresses to uniquely identify both servers. So this is the place where we have all the connectivity and also the other detailed information that Madhavi was talking about. Now let's look at how does the report look like. It's a simple CSV. We have formatted it a bit to make it easier for understanding. So the first column is the device. So these devices are gathered from the primary server, whichever is the primary server, or it could be a device list that we have passed in the CSV, or it could be comma separated list of devices, specific set of devices for which we want to kind of execute this test. So here we have directly gathered all the devices from the server. So first column is the device which we have gathered and for which we are executing the test. And the next column starts with the reports that we have gathered for server 1. Here server 1 is our NSO node 1. So we talked about NSO node 1 and NSO node 2. So we start with NSO node 1 statistics, and then we'll go with server 2. And if there are more servers, then there'll be additional set of columns getting repeated for the same device but on a different server. So what we're essentially trying to do is the same device present in or managed by different NSOs. We are trying to make sure that all the related informations and all the connectivity, everything is proper, and ensuring that in case of a HA scenario, if for example if the master goes down, we want to make sure that the slave is able to manage it. If the connectivity is not there, if there is a firewall problem, then the slave cannot, even though slave can take over, but it will not be able to manage the device. So the objective is to make sure that we are able to kind of manage the device when it is able to move to the other environment. That is, I mean, when the slave is taking over. The other scenarios, we are migrating from one server to another server. So we want to make sure that the other server, or the new NSO server that came up, is able to manage all the devices completely. So the first check is that whether the particular device is existing on that server, server 1. Yes, it exists. The next one is the address, the IP address, and also we can gather the port numbers. And what is the auth group? It's a default one. And is that a NetSIM device? No, it's not a NetSIM device. What is the connectivity status? From the NSO node 1, are we able to connect to the device 1? It failed for some reason. That's where we are saying it has failed here. And what is the net ID? Cisco ISXR. And what is the platform? ISXR. And what is the version of that particular device? 6.3.3, the OS version. And what is the platform model? NCS 5500. And what is the failure reason for the connectivity issue, right? So this is a brief reason. What exactly is the issue? So whatever issue that we are getting back from the NSO, we are kind of giving a full report here. And the next column, server 1, the column L, says that server 1 connect PFR. PFR is the past failure reason. So we are actually passing the failure reason and then giving to a meaningful intent so that we can actually filter out and identify what exactly the issue is. And the next one is the server 1 OS reachability. Server 1 is again node NSO node 1. So we are trying to reach to the device from the NSO node 1. We are doing a ping check. So the ping check went through fine. And we also have another column to just give a small, or I would say minimal status for the ping check. So in this case, it is success, it went through properly. But in case if it failed for some reason, we would have passed it and then given a meaningful failure reason so that it is easy for us to filter. The next one is what all device groups that particular device belongs to on NSO node 1. And next one, the column P talks about, it may be small, I hope it's visible. The column P talks about what all services are affecting that particular device. So if there are more than one service using that particular device, it's going to list down all the service key paths so that we get to know these are the services that are affecting it. And we can also ensure on the other node that still it is the same. The next is the key thing, server 1 stale days. This is something that Madhavi talked about. So here, for this report, we have used 200 days as a stale days, meaning that any device which is not used for more than 200 days, we call them as least used. But the device got onboarded, but there is no change that got pushed from NSO. In that case, we call it as not used. But if you look at this number, it is 172. It's below 200. So what we are terming or what we are classifying this device as is active, meaning that it's still less within the defined 200 days. But 200 days is not static. It can be changed upon the customer needs, your organization needs. You can change it to 50 or change it to 100. So based on that, you will get the current classification of the device. And the next one is saying that, can we delete it? Yes, it is possible to delete it. Can be deleted. So it's not deleted, it can be deleted. And then we also give server 1 deletion status, but again, it's not applicable now because we have not deleted it. In case if you are going to delete, after generating the report, we figured out that these are the devices which is not used, which is not useful. I want to go and delete it. So you can actually do a dry run, and you can also confirm it so that automatically it can go and delete as well. So you don't have to do it manually. So in that case, this particular column T is going to give the report of the deletion status so that you can get to know what is the status of your deletion as well. So next column onwards, we start with server 2. So the same set of parameters that we discussed through means the query parameters and also the checks will get performed on the next server also, NSO server node 2. So that we term as server 2. So it'll span till the end. So if you're having more than 2 servers, then the corresponding set of columns will keep extending. So I'll skip over for the server 2 because it is the same. And the last important thing that we want to kind of highlight here is, so if there are more than one NSO servers managing a particular device, probably like we saw an environment which is having 4 servers, 1 master and 3 slaves, it might take quite a lot of time to kind of identify the connectivity or generate the report for connectivity, right? So it's good to understand how much time it is taking so that you can plan when you want to execute that report, because you cannot execute this report during a peak time where NSO is being utilized. Probably you can think of off business hours. So you can also kind of get an average time, how long it is going to take, and then based on that you can plan how much time it is going to take for these many devices, and you can plan your maintenance window. It's not a downtime, but just to avoid over usage, so we can kind of keep it in off business hours. So this is kind of a information that we are gathering and using which we have built some report. I think over to Madhavi. Madhavi will be kind of walking us through.
Thank you, Ishwar. So that is what the demo about how the reports look like. We would like to share one of the largest service providers, the case study here. So we were asked to migrate environments with the latest NSO versions. The customer is using different varieties of devices, DOCSIS, hub routers, RPA, DPA devices, and then Nokia. So during the process, we all know upgradation process and installations, we do net upgrades and everything. But according to this topic, we run the reports. Depending upon the reports, we have the charts available. So if you observe this chart here, so total how many number of devices, the central one is showing. And then how many are connection successful and connection failed. And then again, connection failed, again having 2 categories, least used and not used. Coming to success, here we have active, least used, and then not used. And then we can see the number depending upon that category. And not only this high-level picture, we were showing depending upon the net type, depending upon the category of the devices. Again, same type of information here, total number of devices and connections, used, not used, and active, like this. So this is like if people are using NSO, we use NSO, but finally we have to manage it. So what is this final report here? Total number of devices are 25,883. And then among those, 16,820 devices are not used, just onboarded to NSO, never did any sync from. That is 16,820. We recommended to delete those devices. And then second category, least used, around 8,636. Actively used devices are 427. So with this report, customer took the decision, like because different people involved to onboard devices and nobody knows who is the owner of those devices. So that's what, this helped them a lot to take decisions finally. So they asked us to delete these 16,000 devices, and then they reviewed these 8,000 devices and then gave us the list of devices which they want to delete from NSO. So not only generating the reports and doing the validation during the migration, we also did the cleanup in the newer environments, and then it improved performance drastically. So what is the takeaway from this scenario? We are not only knowing the devices information of our NSO, and also we are optimizing our NSO CDB. That way we are reducing the memory and CPU utilizations. It leads to the sustainability. So please provide your comments and suggestions. If you want more information about this utility, please send the mail to NSO Device Statistics at cisco.com. Thank you.
Thank you.
Wow, that was fantastic, impressive. So that information should be possible to use in the SUSE framework that Soumya talked about.
Absolutely.
Yeah.
So lots of potential improvements there to save energy.
Yep.
Great.
It may be simple to think about removing a device from NSO, but actually it leads to reducing the memory footprint, and it thereby reduces the CPU cycles required to cross, and it also reduces the power, right? So it's all related.
Do we have any questions? Okay, if you have questions, just approach the speakers. We have one down there. Great.
How do you deal with the services as opposed to the actual config on the device? Removing something with a service that you've previously provisioned, but then not touch the device in 200 days.
You mean service migration?
Well, my understanding is that you're removing the devices from NSO because you're no longer configuring it dynamically. It doesn't have a need. But presumably, it was installed for a reason. And you have an initial service, or how do you do your provisioning such that you can remove the device from NSO and still have it functional?
Okay, so you mean services. So yeah, if you want to take the decision to delete, then we have to delete services also. But here the decision is those devices are not used, no information of the device in NSO.
It was not actually used for service provisioning. It was not. It did not get onboarded because of a service provisioning. NSO was new to them, and the customers got very much interested. And there were a lot of teams, and they wanted to manage all their network devices with NSO. So they took Excel sheets, and then they loaded up all the devices, all the inventory, what they have into NSO.
Thank you.
Yeah. And in case if there are devices which is affected by services, we can still do a case-to-case based analysis. It is going to give the list of there could be some devices which is kind of being linked or referred by some other device. Maybe it's not impacted by the direct service, but it is getting referred by some other service. So in that case also, we are actually getting the back pointers. We'll be able to see what all things that are affecting it, and then we can actually take a case-to-case based analysis. So we have the information, so it will help us to go ahead and remove it automatically as well. We can go and remove the service as well if that's not required. Maybe if we feel that that particular service instance is no longer valid or it's not relevant, maybe that's a old service, we can go ahead and remove it as well.
Thank you, speakers.
Thank you.